Hello students, in today's video I am going to take up very important problems on Fourier series. These problems are very important for the VTU exam 2020. The Fourier series unit is in third semester engineering. So according to the VTU syllabus, the Fourier series unit consists of full range Fourier series, half range Fourier series and harmonic analysis. So here the Fourier series is divided into two parts. One is a full range Fourier series and half range Fourier series. According to the syllabus, in full range Fourier series you are going to study two intervals. One is minus pi comma pi interval, 0 comma 2 pi interval, and arbitrary intervals like minus L comma L and 0 comma 2L. Okay. Now before going to take up important problems on Fourier series, and just briefly I'll explain you what is a full range Fourier series, how to find out the Fourier coefficients, what are all the formula you have to remember to find out the values of Fourier coefficients. Okay. So first interval is the Fourier series expansion over the interval minus pi comma pi. When you have minus pi comma pi interval or 0 comma 2 pi interval, the Fourier series expansion is always f of x is equal to a0 by 2 plus summation n is equal to 1 to infinity an cos nx summation n is equal to 1 to infinity bn sin nx. This is the Fourier series expansion represented by equation 1. When you have, remember, minus pi comma pi interval and 0 comma 2 pi interval. In this video, I am going to explain you only about minus pi comma pi interval, what is a Fourier series expansion and how to solve a problem. In the next video, I am going to take up problems on 0 comma 2 pi interval. If you are not yet subscribed to my channel, please subscribe to my channel to have more and more videos on different topics of engineering like Laplace transform, Fourier transform, Z transform, numerical analysis, etc. So it will be very useful for you if you subscribe it. So please subscribe my channel. So first interval is minus pi comma pi. Now the question is, once you know the Fourier series formula, you have three coefficients a0, an, bn. Do we need to find out all the coefficients a0, an, bn for a given problem? No. So if you have any function like f of x, to find out the Fourier series of f of x, first we will check whether the function f of x is an even function or odd function. According to the function, whether it is even or odd or neither even nor odd, we will find out a0, an and bn. So we will take up three cases actually here. In case 1, we will check whether the given function is an even function or not. I'll take an example, f of x is equal to x square. I have to check whether this function is an even function or not. To check this is even or odd, I'll change x to minus x. Wherever x comes, I'll change it to minus x. So I'll get minus x whole square here. Minus x whole square is nothing but x square. What is x square? Is f of x. So you got f of minus x is equal to f of x. So whenever you get f of minus x is equal to f of x by changing x to minus x, in such a case the function is said to be an even function. If the function becomes even, then bn term in the Fourier series expansion will be 0. You don't have to find out bn, because if it is even means the odd term bn will be directly considered as 0. So find out only a0 and an values. What is a0? The formula is 2 by pi integral 0 to pi f of x dx. An is 2 by pi integral 0 to pi f of x cos nx dx. Okay, find only a0 and an. Second case, case 2. In second case, we will check the function is an odd function or what. If f of minus x is equal to minus f of x, then the function f of x is said to be an odd function. Okay, for example, f of x is equal to x cube, right? If you change x to minus x here, I will get minus x whole cube. That is minus x cube only. You are getting minus sign. So minus f of x I will get. So such a functions are said to be odd function. In odd function what happens? The even term a0 and an will be 0. So a naught an is taken as 0. Find out only bn. Formula is 2 by pi integral 0 to pi f of x sin nx dx. Okay. Third case. If the function becomes neither even nor odd, it is not even not odd, then what to do? Then in such a case, find out all the coefficients a naught, an, bn using the formula. A naught is 1 by pi integral minus pi to pi f of x dx. An will be 1 by pi integral minus pi to pi f of x cos nx dx. Bn will be 1 by pi integral minus pi to pi f of x sin nx dx. Okay, all the three coefficients you have to find out if the function is neither even nor odd. Okay, now we will take up problems. How to find out the Fourier series expansion over the interval minus pi comma pi. I am going to solve old VTU question paper problems because these old question paper problems are very important. There is a chance of asking these questions again. So first we will take up VTU 2009. This question is asked in VTU question paper 2009 in the year 2009. The question is, find the Fourier series expansion of the function f of x is equal to modulus of x in the interval minus pi to plus pi. Okay. So I'll take f of x is equal to modulus of x. The interval is minus pi comma plus pi. So first what we do? We will check whether this function is an even function or odd function. So what is the procedure? Change x to minus x. So f of minus x, wherever x comes I'll change it to minus x. Modulus of minus x is equal to x itself. But what is x? X is plus x, f of x, plus f of x or minus f of x, I don't know. Okay. So we will define what is modulus of x here. Take a look at this figure. Modulus of x means it takes plus value as well as minus value. So f of x is defined as plus x over this region. Okay, minus x over this region. This is the interval 0 comma plus pi. This is the interval 0 comma minus pi. So over 0 comma plus pi f of x value is plus x. Over minus pi comma 0 f of x value is minus x. So that is what I defined here. So from this you can check f of x is taken as plus x directly. So f of x is nothing but plus x. So what you proved? F of minus x is equal to f of x means the function is even function. So f of x is equal to modulus of x is an even function. As I explained you already, if the function is even, what happens? Bn becomes 0. You have to find out the values of only a0 and an. What is a0 then? It will be 2 by pi 0 to pi f of x dx. So 2 by pi integral 0 to pi over the interval 0 to pi. What is the value of f of x? Look at this as I explained you. Over the interval 0 to pi, over here f of x value is plus x, correct? So I will substitute f of x as plus x. Now I will integrate this 2 by pi as it is. Integration of x is x square by 2, limit 0 to pi. 2 by pi as it is. Substitute the limit. Upper limit is pi, so I will get pi square. 2 and 2 you can cancel. Lower limit is 0. 0 if you substitute, it is 0. You will be left with 1 by pi square. Pi and pi goes, you will be left with one more pi. So what is the value of a0? I will get a0 as pi. So next coefficient that we have to find out is what is an. So to find out an, the formula is 2 by pi integral 0 to pi f of x cos nx dx. F of x value is x as you know already. Cos nx I will keep as it is into dx. Now I have to apply Bernoulli's rule of integration by parts to integrate this. What is that rule? The rule is very simple. Don't worry about the rule. Just follow the trick what I will teach you now. Keep the first function x as it is. Integrate the second function. Integration of cos nx is sin nx by n. Okay. Now whatever the function you have integrated, again you have to integrate the same function. So sin nx by n, if you integrate again, you will get minus cos nx, because integration of sin nx is minus cos nx. Nx, one more n you will get, it becomes n square. Okay. Now differentiate the leftover function x, this function u, you have to differentiate. Differentiation of x is 1. It is like this, minus plus, it goes on like this. You have minus here, next term it will be plus. Look at this, you kept x as it is, you have integrated cos nx, you got sin nx by n. Again integrate the same function, minus cos nx by n square. Again differentiate this, it becomes 1. Now after this minus sign you will get plus. This you have integrated, again I will integrate this. Integration of cos nx is sin nx divided by n you will get, that becomes n cube. What you have differentiated? X you have differentiated, got 1. 1 if you differentiate again, it is 0. Next, minus. It goes on like this, minus plus. Okay. Now I will stop here because you got 0 here itself. So what is the limit? Limit is 0 to pi. Okay. Now we need to substitute the limit. Always remember, sin n pi value is 0. Cos n pi value is minus 1 to the power of n. Sin 0 is always 0. Cos 0 is equal to 1. Correct? If you look at all these values and substitute here, what is upper limit? Upper limit is pi. Upper limit pi, if you substitute here, you will get sin n pi. Correct? Sin n pi is what? 0. So this term becomes 0. Lower limit 0, if you substitute here, sin 0 it is, sin 0 is 0. So this term vanishes. And anyway, this is 0 because 0 multiplied by any number is 0. Okay. So what is a term you will be left with? You will be left with only cos nx by n square. N square is constant. I will take outside the limit. Minus into minus plus, only cos nx. Correct? So substitute the limit only for cos nx. Okay. So 2 by pi n square. Upper limit is pi. So cos n x is equal to pi. Minus here lower limit x is equal to 0. So cos 0 I will get. So 2 by pi n square. What is the value of cos n pi? As I told you just now, it is minus 1 to the power of n. Cos 0 is 1. So this is what an you will get. So a0 you got, an you got. Both the values I will substitute back into the Fourier series. That gives the Fourier series expansion of modulus of f of x. What is the formula for Fourier series? F of x is equal to a0 by 2 plus summation an cos nx, n takes the value 1 to infinity, plus bn sin nx, n is the value, takes the value 1 to infinity. Okay. Since the function is even function, bn term is 0. Only you need to substitute for what you got for a0 and what you got for an. What is a0 you got? You got the value of a0 as pi and you got the value of an as 2 by pi n square minus 1 to the power of n minus 1. This is what is an. So both the values I will substitute here. So f of x is equal to a0 is pi. So pi by 2 summation 1 to infinity, an is 2 by pi n square minus 1 to the power of n minus 1. This is the value of an multiplied by cos nx. Okay. So this is what the Fourier series expansion of f of x is equal to modulus of x. So remember, modulus of x is an even function, and since it is an even function, bn term becomes 0. You have to find out only a0 and an. So how to check whether it is even or odd? So whenever you have interval minus pi comma pi, to check whether it is even or odd, just change x to minus x. If f of x becomes plus f of minus x becomes plus f of x, by changing x to minus x, the function is taken as even function. I think you have followed my explanation. If you like my explanation, please subscribe to the channel. Again and again I am telling, because I am going to solve more and more problems on different intervals of Fourier series, and for your examination point of view all those problems will be very important. Bye bye.